Hello and welcome. This is class number 28 of the quick revision series for your prelims 2024. This is the beginning of science and tech. After a lot of days, we have finally completed our geography and environment session. Now we'll be starting with science and technology for the next few days. Most of the questions from science and technology in the prelims examinations are based on current affairs, and that is why please do not miss out on any of the videos of this section as well, just like you have attended all the earlier classes as well. Once again reminding you, you can get the PDF of these classes. All that you have to do is join the Telegram channel. The link is in the description of the video, and there you will be able to download all the PDF. Do hit the subscribe button before beginning if you have not done it so far. So let's begin. The first and the biggest news from science and tech from the last 1 year was the success of Chandrayaan 3. A lot of questions from the prelims and the mains examinations can be expected around Chandrayaan 3. As you know, it was one of the biggest success of ISRO. This project included a lander, included a rover as well, the Vikram lander, Pragyan rover, and that is what makes it even more important. It's a follow-up mission on Chandrayaan 2. Chandrayaan 2, as you know, was not entirely successful. We were not able to ensure a soft landing, but this time around we were successful. The lander module was able to have a soft landing. We also had a propulsion module to carry the lander and rover until 100 kilometer of the lunar orbit. The rover carried out in situ, that means on the surface, chemical analysis of the lunar surface as well. There are a lot of details about this project that you must know. For example, it was launched using the Launch Vehicle Mark III, that is LMV3 from Sriharikota. India has become the 4th country in the world after US, China and Russia to have a successful controlled landing on the moon. Here are a few of the details that you must know. The spot where Chandrayaan 3 Vikram lander made a soft landing, that is now called the Shiv Shakti point. The site where Chandrayaan 2 lander had crash landed because it was not successful, that was called as a Tiranga point. So Tiranga point was for Chandrayaan 2 lander. The date on which the Chandrayaan 2 lander had its successful landing, August 23, would now be observed as a National Space Day in India. So do remember all these informations. There were a lot of different payloads. Payloads basically are different instruments, different machines, etc. that are sent along with that mission to carry out experiments there. These were the main ones: Rambha, LP, the Chaste, ILSA. All these are important. I'll tell you some details about these as well as we go ahead. Here are a few details about the launch vehicle. The launch vehicle Mark III, earlier it was known as a GSLV Mark III. So this is the same thing. It is the heaviest launch vehicle that ISRO uses. GSLV is capable of sending much heavier satellites, much heavier rockets as compared to PSLV. But GSLV uses a much more advanced, sophisticated technology. That is why, while ISRO has mastered PSLV, Polar Satellite Launch Vehicles, GSLV is still a system that has a probability of going wrong sometimes. It is able to launch about 4,000 kg of spacecraft into geosynchronous transfer orbit. Again, the heavier is the capability, the more payloads that you can send and more study you can do on the surface. It is configured as a 3-stage rocket. Whenever you have multiple stages, please remember the first stage will always be solid, because solid stage means that is a stage where the fuel is solid, so you get the most thrust. So to take off from the Earth's surface, you need most thrust. Second stage usually is liquid. Liquid stage has lesser thrust, but it allows you to maneuver, change directions. Third is the most important, the most difficult stage here is the cryogenic stage. That is where you use liquid fuel, but it is able to give you a very, very heavy thrust. Here are a few of the details comparing Chandrayaan 1 and 2. The first one was launched in 2008. Second one was in 2019. While the first one was through PSLV, as I told you, PSLV is ISRO's workhorse, usually always remains successful. Second one was through GSLV and Mark III, because it was able, or we had to send much heavier payloads. The second one involved orbiter and a lander Although the lander was not successful, it crash landed on the lunar surface. These have been the major findings of Chandrayaan 3 so far. Chandra's chased payload has measured the lunar topsoil temperature and has told us it is about 70 degrees centigrade, contrary to initial prediction. So we have made a correction in what we knew about the temperature of the lunar surface of the topsoil. Laser induced breakdown on the Pragyan rover has confirmed presence of sulfur along with other elements, the aluminum, iron, calcium, chromium, titanium, etc. on the lunar surface. Apart from that, Langmuir probe has found a thin plasma on moon's surface, indicating that easy radio wave transmission can happen through the space. So these have been the major findings of Chandrayaan so far. It has identified a 4-meter diameter crater on the moon's surface as well. Second news again is regarding or related to Chandrayaan. As we said, Chandrayaan 3 had many payloads. One of them was the chased probe. Now, what exactly was the chased probe? What did it find? Let's see. Chased here, CHASTE, chased, is basically an instrument that is used to measure the moon's surface temperature at a point below 8 centimeter below its surface, and how the temperature varied as compared to surface and when you go about 8 centimeter deeper. It aims at having measurements of thermal conductivity and temperature profile of the lunar surface, and it aims to go up to a depth of 10 millimeters at the site of the landing. So 10 millimeter equivalent to about 10 centimeter. That is the entire aim of this probe. This is actually also being used to provide thermophysical properties of high latitude region on the moon for the first time ever. So it is again something that is giving us important data, not just for India but for scientists around the entire world, so that when the next probe is sent, you already know a lot more things about the moon and then you can prepare yourself accordingly. Next important payload in the Chandrayaan 3 was a Rambha LP. This, as we discussed earlier, was given the task of measuring lunar plasma over the moon. It has also given very interesting results. This Rambha LP stands for Radio Autonomy of Moon-Bound Hypersensitive Ionosphere and Atmosphere Langmuir Probe. Now, this Langmuir probe is named after Irving Langmuir, who was awarded the Nobel Prize in Chemistry. This payload is being used, as I said, to characterize plasma, that is an ionized gas, on the lunar surface and to see how much gas is present of this kind on the lunar surface. The key features include about 5 centimeter metallic probe operating study for lunar changes near the surface of the moon. It indicates that plasma is encompassing the lunar surface, very very thin plasma, not very thick. The low thickness of plasma is important here because that affects the way radio waves can propagate through the space, and that is why it is extremely important. Unlike the earlier missions that we have sent, these missions are much more advanced because they have been able to tell us many more things. For example, when you look at the Mars orbital mission, in the Mars orbital mission we were successful in sending an orbiter to Mars, but we could not get a lot of information because a lander, something that lands on the surface, will obviously be able to give you much more information than something that is just orbiting. That is why landing on the surface was so much more important, which we were able to do with Chandrayaan 3. Next important news, another successful project by ISRO was Aditya 1, India's first solar mission that successfully reached its final destination, that is the L1 Lagrange point. This is where it was destined to go. It was launched in September 2023, that is last year. The idea was to study Sun from the orbit around L1. L1 is on the Lagrange point and we will discuss that. The launch vehicle used here was PSLV and there were multiple payloads, including the Solar Ultraviolet Imaging Telescope. There was a spectrometer, a coronagraph and X-ray spectrometer. All these have been a part of the Aditya L1 mission. Apart from that, even plasma analyzer package, wind particle experiment, high resolution digital magnetometers were also sent as a part of the Aditya L1 probe. Here are a few goals that this project wanted to achieve, the Aditya L1 mission. Number one, to investigate the upper solar atmosphere. Also to investigate solar flares. Solar flare basically kind of the solar winds that come out from the sun's surface. Also understand the physics of partly ionized plasma. To monitor the in situ plasma and particle environment near the sun. To determine the series of events that take place on the sun so that we can understand the sun better. At the end of the day, sun is the one major source of energy for the entire solar system. So to understand more about the sun, we would be able to understand how it affects our climate, how it affects changes in our weather system, so that we can be much better prepared. Here are a few of the details about the Aditya L1 mission. L1 here again stands for the Lagrange points. Now, there are 5 Lagrange points. Basically, Lagrange point means a place where the gravitational pull of the sun and the earth cancel out each other, so that that particular satellite, that particular mission can have a stable place to stay. So there are 5 such points where a mission can be sent, and at these points the gravitational pull of the sun and the earth will cancel out each other. So there is L1, L2, L3, L4 and L5. L3 not very suitable because again communication from earth will not be possible. L2 not that suitable because L2 is going farther away. L1 is more suitable because again it is the closest to the sun. So if you see it is the closest to the sun, it provides a much better view, and that is why L1 point has been chosen. Apart from this, other countries have also launched certain solar probes. NASA launched something called the Parker Solar Probe. European Space Agency along with NASA launched something called SOHO back in 1996. It has been extended to December 2025. Then European Space Agency also sent a solar orbiter apart from this. So mainly NASA and European Space Agencies have been working to explore the surface of the sun before this as well. Aditya L1 is India's first mission as such. It will carry 7 different payloads as we just discussed. Here are some details about the Lagrange point as we discussed. There are 5 of these points in total. The idea is at these points the gravitational pull of the 2 bodies, that is the earth and the sun, will cancel out each other, and the objects that are placed there will stay there without any disturbance. 2 are stable out of these, 4 and 5, and 3 are considered as unstable, L1, L2 and L3. Again, moving on, one more news regarding ISRO only. As you know, India has recently successfully completed our own navigation system. Countries around the world have their own navigation system. For example, the GPS that you use, GPS that Google Map uses, for example, it's an American invention. Many countries around the world have their own navigation system. They have sent their own satellites so that they can depend on their own system. ISRO has also made its own system called the NAVIC. Now, NAVIC was originally supposed to have 8 satellites and we made it into 7 satellites. One of them did not really function properly. ISRO replaced one of the satellites because there was a problem in the atomic clock. The entire navigation system is dependent on very accurate measurement of time. That is why the most accurate clocks, that is the atomic clocks, which are extremely accurate, they are the ones that are sent. Because when you are relaying information from such a long distance, even a delay of a second can result in a very big error. And that is why it's extremely important that the clocks are very accurate. So ISRO recently sent a new satellite in the NAVIC system. It replaced the earlier satellite so that we can have a much more accurate study. ISRO has launched the NVS-01 satellite using the GSLV. It is the first of the second generation satellites for the NAVIC system. Again, the second generation satellites will be much more accurate. They will have indigenous, means India made atomic clocks. The entire navigation system is based on having these accurate atomic clocks so that we can get the most accurate measure, the most accurate readings about where a particular object is. If you want to go in a certain direction, you need to have an exact location of that object, and that will only be possible through the atomic clocks. This series will use the L1 band signals to widen the existing service. This is developed by ISRO. It's called NAVIC, Navigation with Indian Constellation. The official name is IRNSS, Indian Regional Navigation Satellite System. It's a constellation of 7 satellites. Originally were supposed to be 8, but it's a 7 satellite thing. Total of 8 satellites, but only 7 remain active. 3 are placed in geostationary orbit and 4 are placed in geosynchronous orbit. So difference is, geostationary would mean that, for example, if you are at a single place on Earth, geostationary satellite will always keep on looking at that particular place. So let's say if you want a satellite to always keep an eye over Delhi, so it will basically move just like the Earth is moving. Relative motion will be 0, so that it will always have its eye on Delhi. It will be stationary with respect to Delhi. Geosynchronous are the ones that are in sync with the Earth. Means after 24 hours they will come on the same location. So if right now the satellite is over Delhi, tomorrow again at the same time it will come over Delhi. That is called geosynchronous. So this is the main difference. They are mostly used to cover a distance of 1500 km from our border. So it will not be a global navigation system. GPS etc. that Americans have is a global navigation system. Global system means doesn't matter if you're in Australia, France, US, Saudi Arabia, you can use the same Google map. Because GPS covers the entire Earth, it will work. The Indian system, the NAVIC system that India has, will not cover the entire world. It will be India plus 1500 km from the border. Now the question is, if you open your Google map on your phone, does it mean that now you can use NAVIC there? No. In order to use NAVIC, there have to be some changes required in the hardware of the phone. See, all these systems, all these satellites work on different frequencies. So the existing phones that we have, most of them are basically in line, in sync with how the GPS system is. So in order to bring them to the NAVIC system, to make them compatible with the NAVIC satellite, some changes have to be made. The government of India is pushing some mobile companies to make these changes in the hardware, and some of them have agreed to it, but most of them are still not available in the market. It will take some time for this to actually come up. Just like the navigation system, NAVIC also has a regular standard positioning system that will be open to the public, just like Google Map is. Then there will be a restricted service which will be much more accurate. It will be used mainly by the military. These are the other systems that we have around the world. America has its GPS system. Russia has its system called the GLONASS. China has its system called Beidou. Then we have India's IRNSS. Europe has Galileo. Japan has its own COSI Zenith system. Out of these, India and Japan, these are the regional ones. Means over their country and maybe some other countries in the region. While the others that you see here are global, means they will cover the entire world and not just their own country and their own region. Next news again is related to ISRO. ISRO is collaborating with the Raman Institute to build a new X-ray polarimeter satellite called XPOSat. That is why it is in the news. It is India's first ever polarimeter mission to study the sources of X-ray in extreme conditions. As you know, a lot of celestial bodies in our solar system actually emit X-rays. To study them, to study their composition, to study from where they are coming. That is why this entire project is being done. The spacecraft will carry 2 scientific payloads in the low Earth orbit. Primary payload will be POLIX, polarimeter instrument and X-rays, and it will measure polarimetry parameters, while the other payload will be XSPECT, that will give spectroscopic information to ISRO about the X-ray sources. Polarization, which is the entire objective of this project, refers to orientation of electric field in an electromagnetic field. It is about studying the source of X-rays that will give us information about our solar system, its formation, its past, and maybe its future as well. Not many such projects exist in the world. It is the world's only second polarimeter mission after NASA's Imaging X-ray Polarimeter Explorer called IXPE, launched in 2021. The objective is to study the black holes explore neutron stars, and to also probe active galactic nuclei called AGN going forward. Here are some other details about X-rays. As you know, X-rays are commonly used in hospitals to carry out scan of your bones. It's mainly scanning your muscles actually, but because muscles and bones are reflected with different colors, that is how you come to know about if there is any gap in your bone. It is a kind of radiation, that is X-ray, between ultraviolet and the gamma rays. If you look at the electromagnetic spectrum, it is a radiation that has very high energy and short wavelength as compared to visible light. That is how X-rays are produced in various processes. They are produced from black holes, neutron stars, pulsars, etc. Next news, ISRO, in order to encourage people to take interest in science and space, has launched a program called START, Space, Science and Technology Awareness Training. So ISRO is trying to attract those young people who have an interest in knowing more about space, who have an interest in joining organizations such as ISRO or maybe a private organization. To attract them more towards this field, they have started this START program. The idea is mainly to attract those who are already pursuing undergraduation or in final year of graduation of physical science and technology. It will give entry-level training to these enthusiasts to build more skills about space research in the future. They will be taught about space science, astronomy, instrumentation, etc. The classes will be online. It's an online training program through the Jigyasa portal. Do remember this? Through the Jigyasa portal. This is from where ISRO will be providing training to these youngsters. ISRO already has some other programs similar to this. ISRO has already launched 2 short courses, one on remote sensing data acquisition and other on remote sensing data processing. These are run through the Center for Space Science and Technology Education in Asia and the Pacific. So ISRO has been trying to do this for a long time now, trying to attract more people into this profession going forward. Next, the astronomers in Pune have been able to detect 2 new millisecond pulsars. It's important. What are pulsars? Basically, when a huge star, a massive star, for example the sun, when it runs out of fuel, it dies, it converts itself into a new form called the pulsars. So please do remember this simple definition of pulsars. When huge stars, they have a lot of fuel, energy, when their fuel runs out after millions and billions of years, they end up in the form of pulsars. These pulsars are dense neutron stars and they basically form after collapse of a big star. Also, these are called millisecond pulsars because every few milliseconds they release pulsar radiations. That is why they are called millisecond pulsars. Neutron stars are extremely dense objects in the universe. They are formed when massive stars collapse after their fuel is over. Also, gravitational waves are detected much more easily in these stars as compared to others. That is why discovery of these stars is extremely important. This is how you can define pulsars. They are rotating neutron stars having pulses of radiation, having very strong magnetic field. Also, they have very powerful beam of light. That is how they can be seen. They are formed from explosive death of their parent star and have a mass of 1.4 times the sun. Do remember this, 1.4 times the sun, that is important. Also, another type of neutron star that exists is called the magnetar. This is called magnetar because of its increased magnetic field as compared to other stars. In a normal neutron star, magnetic field is trillions of times that of the Earth's magnetic field. In a magna star, this is even stronger, even 1,000 times stronger than a neutron star. So normal neutron stars have a very heavy magnetic field, but magna stars are even higher when it comes to measuring of their magnetic field, and that is why they are given a specific name for that. Next news, there was a important star. It was in the news because it exploded, called the Betelgeuse. Betelgeuse, a huge star, about 700 million miles in diameter, well known for its orange hue color, one of the largest stars known to our astronomers. It exploded and it vanished. and that is why, and this was basically the end of the life of that star. That's why it is in the news. It was a red giant star, in fact a super giant star. It was a part of the constellation Orion. It was so huge that it was visible from the earth from the naked eye, and it was the brightest star that was visible from here. It underwent a supernova explosion. It was a red supergiant. It reached the end of its cycle. It resulted in something called a type 2 supernova. It was known as a semi-regular variable star for its brightness, because the brightness fluctuated over time, and it sometimes was very bright, sometimes the brightness dimmed a little bit. Apart from the brightness, the size of the star also kept on changing. Sometimes it became bigger, sometimes it became smaller. Do remember this name. These kind of questions are asked. The question, for example, can be Betelgeuse recently in the news refers to which of the following? So the answer here would be a red super giant star. It was a part of constellation Orion that recently exploded. Last news for the first Science and Tech lecture is a comet called Nishimura. Nishimura comet, it was the closest to the Earth these days. It will next visit us after you and me are long gone in 2455. This comet has a very, very long comet period and has a very long, rather estimated orbital period of 432 years. So the next time that you will see it when it is in the orbit nearby the Earth would be after 432 years. As you can imagine, this comet is named after the discoverer called Hideo Nishimura. He discovered it in August 2023. It is located in the constellation Leo, and it will not leave the solar system. It will reach the aphelion in 227. Now, what exactly is aphelion? That is the distant or the most distant point from the sun. Distant point from the sun. So it will be the farthest from the sun in 2227, and it will return around 2430. It will dive near the earth, near the sun. It will intensify, and it will then have a position where it will be visible from the naked eye from the earth. As you know, comets are small celestial bodies who orbit around the sun. Also, they are composed of dust, rock, and ice. When they go near a source of heat, that is sun, you will usually see their tails after them because their ice is evaporating. They also have a glowing green coma that is surrounding them. They are composed of dust. You might see their tail. Tail can be from dust, or tail can also be from the ice that is melting because they are going nearby the sun. That is what comets are. Brings us to the end of the first class of Science and Tech. Do join me tomorrow for class number 2 of Science and Tech, overall class number 29. Be regular here. Do join the Telegram channel to get the PDFs. Thank you so much for watching. Bye bye. Jai Hind.